This is SpaceTime, Series 22, Episode 76. Coming up on SpaceTime, 20 new moons discovered orbiting Saturn, how asteroids affect Earth's climate, and a summer without sunspots. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Well, move over, Jupiter. Saturn is the new moon king, following the discovery of 20 new moons orbiting the ringed world. This brings Saturn's total number of known moons to 82, surpassing Jupiter, which is 79. Each of the newly discovered moons is about 5 kilometres wide. 17 of them orbit the planet in retrograde, that is, in the opposite direction as Saturn's rotation, while the other 3 moons orbit in prograde, the same direction as Saturn spins. 2 of the prograde moons are close to the planet, taking about 2 Earth years to travel once around Saturn. The more distant retrograde moon and the remaining prograde moon each take more than 3 years to complete an orbit. The study's lead author Scott Shepard from the Carnegie Institute says studying the orbits of these moons can reveal a lot about their origins, as well as information about the conditions surrounding Saturn at the time of its formation. The outer moons of Saturn appear to be grouped in 3 different clusters in terms of their inclinations, that is, the angles at which they orbit around the planet. 2 of the newly discovered prograde moons fit into a group of outer moons with inclinations of around 46 degrees, known as the Inuit group, as they're named after Inuit mythology. It's thought these moons may once have been part of a larger moon that was broken apart in the distant past. Likewise, the newly announced retrograde moons have similar inclinations to other previously known retrograde Saturnian moons, indicating they were also likely fragments of a once larger parent moon that had broken apart. These retrograde moons belong to the Norse group, with names coming from Norse mythology. And one of these newly discovered retrograde moons is the farthest known moon around Saturn. This kind of grouping of outer moons is also seen around Jupiter, indicating violent collisions occurred between moons in the Saturnian system or with outside objects such as asteroids or comets that were passing by. The third newly found prograde moon has an inclination of 36 degrees, which is similar to another grouping of inner prograde moons around Saturn known as the Gaelic group, mostly named after heroes from Celtic mythology. But this new moon orbits much further away from Saturn than any of the other prograde moons, indicating it might have been pulled outwards over time, or might not be associated with the more inner groupings of prograde moons. If a significant amount of gas or dust was present when the larger moon broke apart and created these clusters of small moon fragments, there would have been strong frictional interactions between the smaller moons and the gas and dust, causing them to spiral into the planet. During the solar system's early history, the Sun was surrounded by a rotating disk of gas and dust, out of which the planets eventually formed. And astronomers believe a similar scenario would have happened on a planetary scale around somewhere like Saturn. The fact that these newly discovered moons were able to continue orbiting Saturn after their parent moons broke apart indicates that these collisions occurred after the planet-forming process was mostly complete, and where the dust disks were no longer a factor. The new moons were discovered using the Subaru telescope atop of Mauna Kea in Hawaii. And undoubtedly, they won't be the last. You're listening to SpaceTime. Still to come, plans for an orbital hotel around the Earth by 2025, and a summer without sunspots, with the Sun undergoing an incredibly deep solar minimum. About 466 million years ago, a pair of asteroids collided in the main asteroid belt between the orbits of Mars and Jupiter. The impact generated a huge amount of space dust which spread right across the inner solar system. The Earth would have also been bathed in all that dust, increasing stratospheric dust levels by between 3 and 4 orders of magnitude. Scientists say that's enough to have triggered an ice age by blocking sunlight and reflecting it back into space, before eventually floating down onto the Earth's surface. This dust, which has been identified as coming from the breakup of an L chondrite asteroid, was found in sedimentary samples taken from near St. Petersburg in Russia and from the south of Sweden. Now, a new report in the journal Science Advances suggests the amount of dust from this asteroid collision was enough to trigger a major climate-changing event known as the Ordovician glaciation, which caused a major cooling of the planet and a significant amount of biological diversification. The Ordovician glaciation is the first part of the Andean-Saharan glaciation and is the leading cause of the Ordovician Silurian extinction event. Evidence of this glaciation can be found in places as far apart as Morocco, South Africa, Libya and Wyoming. The evidence derived from isotopic data suggests that during the late Ordovician, tropical ocean temperatures were 5 degrees Celsius cooler than the present day, and that would have been a major factor that aided in the glaciation process. The late Ordovician is the only glaciation period that appears to have coincided with a mass extinction of nearly 61% of marine life. It's thought to have lasted somewhere between 1 million and 35 million years, generating between 50 and 250 million cubic kilometres of ice sheet volume. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
Now, Fred, we are going to look at this particular asteroid smash-up, as they're describing it, which dates back 460 plus million years. And now it's thought that this particular event may have caused an ice age on Earth. That sounds rather unusual or interesting, or both.
Yeah, it's. I mean, when we talk about asteroids, we particularly prehistoric ones like this, we think of the dinosaur smash-up, the dinosaur asteroid collision, which happened 66 million years ago, and basically an asteroid hit the surface of the Earth, something maybe about 15 kilometers in diameter, and the debris from that explosion, from that impact, very quickly blanketed the Earth with dust and debris and caused a sudden drop in temperature. And this is a drop that might have only taken months or even days or weeks rather than years or decades. It was very quick, and it's that caused the demise of the dinosaurs, because they basically had nowhere to go. That thing happened so quickly that their environment was effectively totally destroyed.
Yeah, that's why goldfish die. People pour cold water into a fish tank. It's the same thing.
There you go. There you go. A little bit of folklore from Andrew Dunkley. Don't pour cold water into your fish tank.
No, they need to acclimatise.
It's got the same effect as the asteroid had on the dinosaurs. But this is a different sort of collision. There is evidence, and I'll come to that in a minute, but there is evidence that about 466 million years ago, 400 million years longer back in the past than the dinosaur demise, there was not a collision of an asteroid with the Earth, but a collision of an asteroid with another one, probably a smaller one.
Hence the smash-up.
Yeah, the big one is thought to have been 150 kilometres in diameter, which is actually 10 times the diameter of the one that killed off the dinosaurs. So you've got this object, 150 kilometres in diameter. Something runs into it. Probably it may even have been one as big, but whatever it was, there was an impacting object, which effectively demolishes the big asteroid, reduces it to rubble. So that basically has a number of effects, but the bottom line is it fills up the inner solar system with dust. So there's some interesting numbers here. We know that something like 1% of the dust in the Earth's atmosphere today is from a meteorite. It's meteoritic.
Yeah.
But the few million years after that breakup of that asteroid, 466 million years ago, that put 10,000 times more dust into the Earth's atmosphere. So it just means that the meteoritic dust increases by a factor of 10,000. And so what you've got is a blanket of dust in the Earth's atmosphere that reduces the temperature. What you also have is dust in the inner solar system, which reduces the amount of sunlight that's coming from the sun to the planet. So you've got a double whammy here. The sunlight's reduced, but also the opacity of the atmosphere, the light that it absorbs or shadows, that also reduces the radiation falling on the surface. So for a long period, the Earth's temperature is lower. Now, the evidence for this comes from micrometeorites in the geological layer that coincides with this 466 million year old impact. The geological layer over a period of, I think, something like 2 million years is characterized by these micrometeorites in the strata. I think they are approximately the size of a coin. They're quite small. They're just little bits of debris, but they tell you that there is also dust in the atmosphere. Micrometeorites are what tell you that there was a lot of stuff in the Earth's atmosphere, because that's found its way into the geological record. Mm-hmm. But it's a slow process. This is the key thing. And that is the really interesting part of this story, because Yes, exactly as you've said, it created an ice age. But that ice age was so gentle and slow in coming that, unlike the phenomenon where the dinosaurs were wiped out, what happened is evolution was ahead of the game. So species evolved because of the fact that the temperature was cooling. They evolved to cope with that. And actually, instead of an extinction, you get what is known in the trade, apparently, as the Great Ordovician Biodiversification Event, or the GOBI, Great Ordovician Biodiversification Event. And that's telling you that there were more species, huge blossoming in the number of species. One author commenting in this on Cosmos web page is actually Richard Lovett, who's always got away with words. He talks about there not a mass extinction, but an evolutionary kick in the pants for life to adapt. And that's what gave you this GOBI, the Great Ordovician.
So in real terms, it was the opposite to the dinosaur asteroid.
Yeah, right.
And it was a slow burner, and life kind of just exploded as a result of the effects of this.
Yeah. That's right, which is a bit counterintuitive, but the commentators on this work who are not connected with it, they seem to like the idea. They think that's a really good explanation for this biodiversification event that until now I think has lacked a mechanism that would have caused it. So really interesting stuff. And as you said, counterintuitive, although there is a big difference between between an asteroid hitting the Earth and two asteroids colliding in between Mars and Jupiter in the main asteroid belt.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. The Sun has been undergoing a remarkable period of sun-spotlessness. A report by spaceweather.com says that during the northern summer of 2019, the face of the Sun was blank and without sunspots more than 89% of the time. That makes this one of the deepest solar minima in a century. Interestingly, the summer of 2019 also brought a sign that the solar minimum is finally coming to an end, meaning a new 11-year solar cycle is now underway. From time to time, we get inquiries from our listeners asking how they can support our show. And that's why we've set up a Patreon account. For just a few dollars a month, you'll get access to a slick commercial-free double-episode version of the show each week, as well as bonus audio content not included in the regular show, plus other rewards like an invitation to join our special patron-only Facebook group. You can get all the details at Patreon, spelled Patreon, patreon.com/spacetime with Stuart Gary, where you can see the various reward levels available and what works for you. And of course, you'll have the satisfaction of knowing that you're helping us develop our show into the future. That URL again, patreon.com/spacetime with Stuart Gary. And you can find all the details in the show notes, or just click the orange button on our website. And thanks to all our patrons, because it's your generosity and support that helps keep our show going. Well, it's not the year 2001 Space Odyssey just yet, but promoters claim they will have the world's first space hotel operational by 2025. The company behind the ambitious project claim their Von Braun space station, yes, it's named after the Nazi rocket scientist, will offer cruise liner levels of comfort, luxury cuisine, and even artificial gravity, although they will have to drink water partly recycled from sweat and urine. And just like 2001 A Space Odyssey, the Von Braun space station will be ring-shaped with 24 residential modules accommodating up to 400 people at a time, taking in around 100 new visitors every week. Of course, whether any of this dream becomes a reality within the next 6 years, for that matter within the next 60 years, is quite another thing. Back during the space tourism boom at the turn of the century, people paid between $20 million and $60 million for a ticket to ride aboard a Russian Soyuz capsule to the International Space Station for a stay of just over a week. And the promoters of this new project admit price tags for a visit to their space station will be every bit as astronomical as the views. Still, they expect plenty of cashed-up millionaires and billionaires to visit the new ultra-exclusive resort. But as to that name, the Von Braun Space Station, still, I guess it could be worse. They could have named it Hotel Hitler. No, we won't go there. Russia has launched a new top-secret military spy satellite designed to monitor enemy missile launches. The highly classified mission was flown aboard a Soyuz 21B rocket equipped with a frigate upper stage from the Plesetsk Cosmodrome 800 kilometers north of Moscow. Although no official details of the flight have been released, NOTAMs, that is Notice to Airmen warnings, were issued for impact sites for spent rocket stages in southern Russia and over the Pacific Ocean southeast of Tasmania. Now, that means the 4 strap-on boosters would have been ejected downrange over marshland at the S28 impact site some 350 kilometres to the south of Plesetsk, and the payload fairing would have then fallen into the western Siberian plain. The core stage would have separated and crashed to the ground some 1,500 kilometres downrange from the launch pad at a location designated as the S21 impact site, with the third stage finally deploying the frigate upper stage and satellite and then deorbiting southeast of Tasmania. Now, all that matches the exact ground track for 2 previous EKS Tundra satellite launches, which were flying the Kremlin's newest ballistic missile early warning system constellation. So, we can be fairly certain that this launch was indeed one of the new Tundra satellites. So, what do we know about these spacecraft? Well, each satellite weighs 3,250 kilograms. This one went by the pseudonym of Cosmos 2541, and it would have been placed into a Molniya orbit designed to keep it above the Arctic Circle for as long as possible on each orbit of the planet, allowing it to keep a wary eye out for any potential missile launches over the North Pole. Beijing is yet to confirm reports that its new next-generation ChinaSat 18 telecommunications satellite has failed shortly after being placed into orbit. Launched aboard a Long March 3B rocket from the Zhaichang Satellite Launch Center, the spacecraft apparently failed to deploy its solar arrays, needed to supply power to the satellite. The ChinaSat 18 was the first spacecraft based on a new enhanced version of the Chinese DFH-4 satellite platform. The official Chinese Xinhua news agency has reported that the spacecraft was experiencing anomalies and that engineers were investigating the issue. A new issue of Australian Sky and Telescope magazine has hit the newsstands, and this month's cover story looks at the science and history of Earth-orbiting X-ray telescopes. These instruments are designed to observe remote objects in the X-ray part of the electromagnetic spectrum. In order to get above the Earth's atmosphere, which is opaque to X-rays, X-ray telescopes are flown aboard high-altitude rockets, aboard balloons, and more recently, aboard artificial satellites. Many of the existing telescopes on satellites are compounded of multiple copies or variations of a detected telescope system. Joining us now with the details is Australian Sky and Telescope editor Jonathan Nally.
Stuart, in the October issue of Australian Sky and Telescope magazine, we take a look at the sky with X-ray eyes, or rather X-ray telescopes. Because
I think Superman's got the franchise on X-ray eyes.
Has he? Well, he hasn't got the franchise on X-ray telescope, and that means satellites, because you have to get above Earth's atmosphere in order to see the sky in X-ray light. That's because Earth's air blocks almost all X-rays coming in from outer space, which, let's face it, is a pretty good thing, otherwise we'd all get fried. But for astronomers, being able to study the universe in X-ray wavelengths is really important, as many of the most, really energetic and violent sort of phenomena in nature give off X-rays. The light inside your room gives off visible light because that's what wavelengths are given off by a device of that temperature.
Humans are actually brightest in infrared.
Yeah, if you put an infrared detector onto a human, you'll see that we're glowing in infrared, which is sort of heat. And the sun's really hot, of course, but things out there in space that are really violent and energetic, we're talking about like black holes and colliding pulsars and even really hot gas being squeezed, gives off X-rays. This is the sort of stuff we couldn't see from down here on the ground until we got satellites up into space. So in this issue, we take a look at all these satellite missions, the whole history of X-ray observatories up in space. They've really opened up our eyes to a realm of the universe that we could never have hoped to have seen from the ground.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. The World Health Organization now says some 7 million premature deaths per year are linked to air pollution. Air pollution affects human health in a multitude of ways, from heart and respiratory diseases through to asthma and even people's cognitive abilities. For the past 2 decades, the European Space Agency has been tracking air pollution on a global scale, monitoring where it originates and how it spreads across the planet. The latest orbital weapon in atmospheric pollution monitoring is ESA's recently launched Copernicus mission Sentinel-5 precursor spacecraft. Sentinel-5P uses an advanced spectrograph called TOPOMI, which is 10 times better resolution than any previously flown. This allows Sentinel-5P to monitor air pollution and even forecast dangers in advance, warning people about potential bad smog days in their region before it hits. This report comes courtesy of ESA TV.
The atmosphere, crucial for life on Earth. It makes our planet habitable. However, air pollution has become a serious problem. Human activities are altering our atmosphere at an unprecedented scale. This has an impact on air quality and is affecting people's health all around the globe. Studies even show that in the urbanized regions of Europe, 90% of the population is exposed to harmful levels of air pollution.
According to the World Health Organization, adverse air quality is responsible of 7 million premature deaths on a global scale. In Europe, the European Environment Agency estimates to 400 to 500,000 premature deaths occurring. So this is a very real problem.
Air quality affects our health in many ways, from causing heart and respiratory disease to exacerbating asthma, and even impacting cognitive abilities. Recent studies have also shown that even relatively low levels of air pollution can affect people's health. In order to better understand this problem and find solutions, scientists need reliable data on where and how the air is being polluted and how it spreads. This can be done locally by taking in situ measurements. But with satellite data, this can be achieved at a larger scale, across regions and countries, thus tracking pollution as it's spread by the wind. Over the last 2 decades, the European Space Agency launched a number of satellites that observe our atmosphere and measure air pollutants.
ESA is involved in air quality measurements by providing space measurements, satellites that have the capability to measure air pollution trace gases. We started on this during 1995 by putting GOME in space. This instrumentation, this capability has then been improved step by step by follow-on instruments like Skiermaki, GOME-2 or OMI. And now with the Copernicus mission, Sentinel-5 precursor, we have global coverage within 1 day. And this allows for the first time to use this space-based measurements to be implemented in operational services for air quality monitoring, but also for forecasting.
The Copernicus program with its Sentinel satellites has bridged the gap between research and operational services. Using both satellite and in situ measurements, the Copernicus Atmosphere Monitoring Services provides information about air composition and quality across the globe. At the European level, it's almost like a weather forecast. This information is picked up by media and smartphone applications, warning the public on poor air quality in their region. With Copernicus Sentinel-5P launched in 2017, which carries a novel instrument called TOPOMI, a big step was taken to observe sources of air pollution. Now pollution hotspots are clearly visible. This increased spatial resolution comes from Sentinel-5P spectrometer, the TOPOMI instrument.
The TOPOMI instrument is really a big step forward in what we can do, and that's for different reasons. I think maybe the most striking thing when you look at the data is the very good spatial resolution. So it can measure with a ground resolution of about 3.5 by 7 kilometers, which is more than a factor of 10 better than what we can that previous instruments had.
With its TOPOMI instrument, Copernicus Sentinel-5P is showing how important it is by delivering operational data on air quality every day. Within the Copernicus program, ESA and the EU are already preparing new missions to monitor our atmosphere. For example, one of the potential future Sentinel missions has been proposed to monitor emissions of carbon dioxide. Our atmosphere is precious, but polluting emissions are both responsible for poor air quality as well as adding to the greenhouse effect driving climate change. By monitoring emissions and understanding how they spread, we might find solutions to keep our planet breathable and sustainable.
And that report by ESA TV included Vincent Henry Pugh, head of the Copernicus Atmospheric Monitoring Service, Klaus Zeno, the Sentinel-5P mission manager with ESA, and Pepin Vivkin, the principal investigator with the Sentinel-5P TOPOMI instrument. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. The extent of Arctic sea ice at the end of this Northern Hemisphere summer season has effectively tied with 2007 and 2016 for the second lowest level since modern record-keeping began. The analysis of satellite data by NASA and the University of Colorado Boulder shows that the 2019 minimum extent, which was likely reached on September the 18th, measured just 4.15 million square kilometres. The Arctic sea ice cap is an expanse of frozen seawater floating on top of the Arctic Ocean and neighbouring seas. Every year it expands and thickens during the fall and winter and grows smaller and thinner during the spring and summer. But over the past few decades, increasing temperatures due to man-made global warming have caused marked decreases in Antarctic sea ice extents in all seasons. A study of over 3,000 people aged over 72 has found mentally healthy teetotalers were more likely to develop dementia than people who consumed a little alcohol. And when I say a little, we're talking about less than 1 drink a week. The findings, reported in the Journal of the American Medical Association, also suggested that among people who started the study with mild cognitive impairment, drinking more than 14 weekly drinks was associated with an increased risk of developing dementia compared to those who drank just a little, again less than 1 drink a week. While this study cannot show cause and effect, the authors say the results suggest the relationship between alcohol consumption and dementia is extremely complicated. Scientists arriving in Brisbane after a 28-day voyage to the Coral Sea say they're amazed by their discoveries in the deep sea. These included never-before-charted 5-kilometre deep seafloor canyons, unnamed volcanic seamounts, and likely new species of deep-water coral. The new discoveries came on top of the main work of the voyage of the CSIRO research vessel Investigator, collecting rock samples from volcanic seamounts to enable a better understanding of how the region formed and surveying the distribution of important marine habitats. New research by scientists at Perth's Curtin University into how Earth's rocks formed billions of years ago has helped unlock the mystery of how the planet's unique plate tectonic behaviour changed over more than 4 billion years. Scientists found that by comparing the temperature, pressure and age of ancient rocks, researchers found plate tectonics evolved gradually over the past 2.5 billion years as the Earth slowly cooled. You can read the findings in full in the journal Nature. A new study from the University of Copenhagen reports that the prevalence of overweight dogs is remarkably larger among overweight owners than among owners of normal weight. The findings, reported in the journal Preventative Veterinary Medicine, show there's some truth in the old saying that dogs tend to look like their owners. The study of 268 adult dogs showed the prevalence for heavy and obese dogs is more than twice as large among overweight or obese owners than among owners who are slim or of normal weight. Scientists say part of the explanation rests upon how owners manage doggy treats. Whereas normal-weighted owners tend to use doggy treats for training purposes, overweight owners prefer to provide doggy treats while relaxing on the couch and sharing the last bites of a sandwich or a cookie with their doggy. But then again, when you're eating something and Fido's looking at you, how can you say no to that face? France is to end healthcare refunds for homeopathic treatments. The new policy, which has drawn strong criticism from the advocates of alternative medicine, will take full effect in 2021. Tim Mendham from Australian Skeptics says the French government have simply looked at the science and realised that homeopathic medicines simply don't really work.
This is big news. This is probably one of the biggest announcements in the alternative medicine thing for a while. What's the equivalent, as you say, at the national health, the state health system in France, is downgrading its reimbursement of homeopathic treatment to eventually sort of withdraw all funding by about 2021. So far it funds, it's like Medicare, and it funds a percentage of the doctor's fees, etc., and the things you have to pay. It's saying homeopathy doesn't work, there's nothing there to sort of support it, so we're sort of withdrawing that funding for homeopathy. You can still get homeopathic treatment, but you've got to pay for it yourself. The government, and therefore the taxpayer, is not going to support it. This is following on things that in the UK, they're doing the same with the National Health Service. You're not talking huge amounts of money, although in France, homeopathy is very popular. I reckon you'll be finding the same sort of thing in Germany, where homeopathy was founded 220 years ago. And of course, in Australia, Medicare does not support homeopathy. You cannot get Medicare coverage for homeopathic treatment. You still get it if you want to pay for it. And recently, of course, that the insurance companies, the health insurance companies have been told they cannot fund homeopathy and a range of other sort of dodgy sort of alternative medicine treatments. Naturally, this has upset a lot of people, especially in France, where about 1 million people have signed a petition. Homeopathy is very popular there. Most pharmacists would sell homeopathic treatments, but it doesn't make it any more sort of effective. Germany, there's a lot of opposition now, a lot of more organised opposition to homeopathy. A lot of it's been inspired by our National Health and Medical Research Council report on homeopathy about 4 years ago, which found there was absolutely nothing there.
That's Tim Mendham from Australian Skeptics. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.